All right, some speed of light questions. This is specifically dealing with the Michelson experiment for finding the speed of light. Now, the first aspect of this, and really this is the major trick to all of this, because essentially all speed of light questions really come down to using the formula V is equal to D over T. However, finding that time for something that moves so fast is really tricky. Now, Michelson used a multi-sided mirror, and to find the time for that mirror essentially comes down to us using the period and frequency, and the number of sides that it has. So if we think about the time required for an 8-sided mirror rotating at 520 hertz to rotate only 1/8 of a turn. Well, first of all, we can find the time it takes to make one complete rotation. That is the period, which is related to the frequency. So period is equal to 1 divided by the frequency. We wind up with a time of 0.0019 seconds, but we don't want it for one complete rotation. We want it for 1/8 of a rotation. So really this is just dividing by 8 to get you 2.4 times 10 to the negative 4 seconds. A second example here. Here we've been given this in rounds per minute. That's what RPM stands for, rounds per minute. And so first of all, we're going to take the 28,000 RPMs and divide it by 60 in order to get how many rounds per second, or 466.6 rounds per second, which we know is a hertz. And so that is your actual frequency. Now this runs just similar to number 1. Period is equal to 1 over the frequency. This frequency here is 466.6 repeating seconds, which means that we have a period of 0.001214. Jumped a little ahead there with the writing. 214 seconds. But again, because we only want for 1/10 of it, you're going to divide by 10 to get the time for a 1/10 being 2.14 times 10 to the negative 4 seconds. All right, pause this video now. Give number 3 a try. Check with your teacher, and then come back and take a look. All right, we are back. Now, in the case of the Michelson experiment, you had a multi-sided mirror. Light would generate from that mirror, go a tremendous distance, a tremendous amount of distance back in order for light to be observed. Now, in this case here, this distance gets traveled twice, and usually it's in the kilometers range. And during that time, we're seeing that make one portion of rotation in order for the light beam in order to come straight through. So if we take a look at a couple more examples, okay, 8-sided mirror, rotating at 500 hertz, located 36.2 kilometers away. That should say 36.2 kilometers. From a fixed mirror, the returning light is observed in the system. At what speed is the light traveling, or measured to be traveling? Well, the time that we're looking for is for 1/8 of this mirror rotating. And so like we did before, 1 over frequency, 500 hertz means that the period is 0.002 seconds, and for 1/8 of rotation, it's 2.5 times 10 to the negative 4 seconds. And so the time it takes for light to travel all this distance is only 2.5 times 10 to the negative 4 seconds. The distance traveled is 36.2 kilometers times 2, there and back. So that gets you 72.4 kilometers, or 72,400 meters. Now that we have distance and time, the velocity of light can be found using the velocity formula, or the speed formula, distance over time, displacement over time. You wind up with this calculation being 2.89 times 10 to the 8 meters per second. One more example to just try here, or just to go through here before you move on to your questions. Speed of light is measured to be 2.98 times 10 to the 8 meters per second using a 16-sided mirror, with the distance separated 5 kilometers away, or 5,000 meters away. So the total distance traveled is going to be 10,000 meters, twice that distance, there and back. 16-sided mirror, well, this is essentially just working backwards. First thing we're going to do is we're going to find the time, which is distance divided by the velocity. The velocity being given to us, we find that the time is 3.36 times 10 to the negative 4 seconds. Incredibly fast. Well, that's the time that it took for this mirror to rotate 1/16 of a rotation. So the period is going to be 16 times that amount, because that's 1/16 of rotation. So the full period is 0.00536 seconds. Okay, because that will make for one complete rotation. Lastly, frequency is now 1 over the period. So we'll take that 1 divided by 0.00536, or 187 hertz is the rotation of this mirror. Okay, give this last one a try. Check with your teacher before moving on to your homework.